Section 3.2 is the first place that we'll see the normal distribution in this class. The normal distribution is one of, if not the most important tools or concepts in statistics as a whole. And certainly in this class, the normal distribution is something that we're going to see over and over again. And in this section 3.2, we're really just introducing you to what the normal distribution is, and also a few of the basic calculations we can do once we know that something follows a normal distribution. So what we're looking at right now is a typical normal distribution. This is the standard normal distribution with mean 0 and standard deviation 1. This is often referred to as a bell curve, but I'll warn you, lots of bell-shaped curves aren't normal distributions. When you call something a normal distribution, you're making a very specific claim. You're saying that it follows an exact shape. So you shouldn't refer to something as normal unless you know it follows a normal distribution. And conversely, when you're told something follows a normal distribution, you know a ton about it. Because even though there are lots of normal distributions, it turns out that they all have the exact same shape. And I want to show you what I mean by that. So one thing I could do is take this normal distribution and move it to the left a little bit. So there's a blue graph. Now this is a different normal distribution, but it's really kind of the same thing, right? I just took the first graph and I changed its mean from 0 to -2. Another thing I could do with a normal distribution is I could stretch it or squish it. So in this graph, we notice that I took my normal distribution and I shrunk it down. And you might say, wait a second, you also stretched it out. And that's because all of these things have an area of 1 under them. They're all probability distributions, so the total area has to be 1. So when I squished it down, that would make the area smaller under it, and so I had to stretch it out to bring the area back to 1. And so again, this is, I guess in some ways, a different normal distribution, but it's really as if I just distorted the image by stretching it and squishing it. So it's not really a different shape. It's just changed scales of things. And then finally I could, and I guess I should say this corresponds to increasing the standard deviation. This normal distribution has a mean of 0 still, but has a bigger standard deviation. That is, values are more spread out. The final thing I could do is some combination of these two, right? So I could squish or shrink it and move it to the side 1. That is, change the standard deviation and change the mean. But again, I'm not really changing the shape of this distribution. So the point is, the normal distribution is a very specific shape. Different normal distributions have different means and different standard deviations, but once you know the mean and the standard deviation, you know everything about the normal distribution. There is only one normal distribution with a given mean and a given standard deviation. And what this allows us to do is to perform calculations when we know that something follows a normal distribution. We'll see in this course that one of the main reasons that the normal distribution is so important is that when we try to estimate population values using sampling, we often get, in various situations, a normal distribution of values from the sample. So the calculations we're going to do now are going to be important throughout the course. In this section, we're going to do just basic calculations with basic normal distributions that don't involve sampling. But what we'll see is that we can, if we know the mean and standard deviation of something that follows a normal distribution, we can, for instance, figure out what percentage of values will fall above some number, or below some number, or between two numbers. And conversely, we can also figure out percentiles. So we could calculate, for instance, the 90th percentile of a data set. That is the value below which 90% of all other values fall. So when we have a normal distribution and we know it's normal, we can do all sorts of calculations. And that's one of the big goals of this section, is to figure out how to do those calculations so that later when we use them in particular in sampling, we'll already know how to do that.